All right, here we go. Our objective for today, I can solve one variable equations. Once again, I can solve one variable equations. Before we continue, tell your neighbor what is the main concept for today. Main concept. Go. All right, so if you notice, we're going to go into solving from now on. We're done with expressions and we're moving on. So really quick, writing utensils down, look up. I'm going to show you the roadmap where we've been so far and where we're headed, okay? So we started off and we talked about real numbers. You guys remember that? And then we said real numbers were into two parts. They had rational and irrational. You guys remember that? And then we gave examples and so on and so forth. And I said where we're going with algebra 2 and all that. Once we get there, we're getting into no longer real numbers. We're going to be looking at what? Imaginary. From there we gave examples of that. And then I said when we combine both together, tell your neighbor what those are called, please. Complex. That is correct. So when we combine real numbers with imaginary, we get a complex. So from there we did a lot of stuff with expressions. We simplified and evaluated and also translated. But from now on, now we're going into equations. And to be specific, today we're looking at one variable equations. So if it looks kind of like a pattern, what would you think the next thing would be after one variable equations? From there we go to two variable equations. And of course that brings the stuff that you love, like the slope, the graph, and all that fun stuff. And then from there we go to funner stuff. From there, now that we covered that, we go into systems of equations. And now we use not only one equation, but we use 2 to 3 different equations to solve any system. From there, I'm going to introduce also and bring back quadratics. You guys remember those? Polynomials. I'm telling you, they never leave. They never leave. They're going to continue coming back, so we need to revisit that. And of course, every step of the way, before we get to functions, I'm going to, at the end of each part, we're going to get to inequalities in one variable and inequalities in 2 variables, and systems also in inequalities. Okay? And then after that, we get started and we get going with functions. And I'm pretty sure you guys remember functions, right? We're going to start from there for algebra 2 and continue on. Okay? All right, here we go. So with that said, one variable equation. So for those of you that did not have me in the past, here it goes. I'm going to clarify a couple things. The first one, when I introduced one variable equations, I introduced it a couple of ways, but one thing I did explain to my students that back in the Roman Empire, back then they used to have these scales in the market and used to go and shop and used to get those to weigh and give products for whatever you purchase. And I said, if you walk away from there, you see the bar that's straight on the balance, it's balanced, and then you see the bar of the table. You guys see the table here, sideways, or far away, yeah? And I said, and those two make what symbol? The equal sign. So equations basically is focusing on a balance scale that it needs to be balanced. That's why if it's not balanced, that's why we say in mathematics, what do we say? Whatever you do to one side, you do to the other to keep it balanced. And one of the key things that I told my students whenever they are solving equations to get started, draw a line down the equal sign to remember that there's 2 sides to the equation. And that those simple little things pay dividends at the end. It makes a difference. So I'm going to walk you through the baby steps of this. Okay? Let's get started. One variable equations. What are they? One variable equations are 2 expressions equal to each other and contain one unknown variable. 2 expressions equal to each other and contain one unknown variable. 2 expressions equal to each other and contain one unknown variable. Copy that. Examples, copy these, please. X plus 2 equals 25. 12 equals y minus 8. 2a equals 14. Negative 3 equals m over 4. I'll zoom into those so you can see them. There they are. All right, according to definition, here goes. According to definition, I'm going to break down each one of these to see if it's true. The definition said two expressions equal to each other in one variable. Let's see. Is this an expression right here? Yes. Is this one an expression by itself? Yes. Are they equal to each other? Yes. Do they have only one variable in the whole statement? Yes, there it is. Is it the same thing here? Yes, yes, and yes. Therefore, these are called one variable equations. Let me show you some more examples. You don't have to copy these just so we can go a little bit more expeditiously. Here it goes. Look up. Let's see. Expression, expression, equal to each other, one variable. Yes? Same here, and same here. All right? Any questions in regards to what we're looking at in regards to one variable equations? All right? Here, let me show you what they are not. None examples. Look at these. As you copy those, start thinking, these are not one variable equations because, in your noodle, just answer that, in your noodle. All right? Share with your neighbor, let them know why each of these is not a one variable equation. Go. Start with this one. Now that you talk about it with your neighbor, Lene, why is this one not a one variable equation? It doesn't have an equal. So what will we call this? An expression. Bam. Pass it to someone, Lene. Pass it to the person that actually said something in the back. There you go. The next one. Why is this one not a one variable equation? An inequality. So what would we call that one? Look at it. Take your time. Very similar to these, but now it has an inequality. Have someone, brother? Jordan, what's the name of it? Look at it. The top one is an expression. This is an inequality, but what kind of inequality? Look at it. You got it. You got it. Look at these. Look at this. One variable inequalities. That is correct. Let's go. All right, pass someone. Jordan. Jake, why is this one not a one variable equation? Because as the exponent, when we get to quadratics, remember that it's equal usually to y, and then we solve for y, and so on and so forth. So yeah, this is a two variable equation. Pass someone, Jake. Aileen, how about the last one? So what is this one called? Two variable equation. That is correct. So does everybody understand the difference between one variable to two variable? Yeah. So on the critical attributes, I want you to give me some hashtags. If you were to snap this to someone or whatever, at least 2 to 3. All right, Jolene, pass someone. Josh, hashtag what?
One variable.
One variable. Pass someone.
David.
Damn. That is good. Have someone? Ramon, last one. No exponents. Yeah, I'll take that. And then you have some other ones, that's fine. Okay? All right. From there, we're going to take, underneath that, I want you to write the steps that we're going to be using. But instead of writing the whole thing, we're only going to write one word per step. First step is what? Simplify. From there, we isolate. From there, we plot. And from there, we check. And we're only going to do that for the simple equations. But afterwards, we're no longer going to plot and check. I just want you guys to get used to the format before we get to inequalities. So as you're copying the 4 keywords, let me elaborate on step 1. Step 1 says simplify each side of the equation. Why is it that we can simplify each side? Because each side is an expression, is that correct? We can simplify its lowest terms. Step 2, isolate. Now, for those of you that don't understand this word, let me apply it to something that you know. Now, I know that you guys don't get referrals, but you have friends that have, right? So in referrals, there's this one section where the teacher writes, student was isolated. So what that means, I don't know if you saw your friend, the teacher told him to sit in a different spot, or they kicked him outside of the class while they issued the referral. Isolation means that they are by themselves. So same here. You need to isolate the variable. What does that mean? Leaving a variable by itself. Okay? And lastly, we plot the solution on the number line and check. All right? So, we got that? So, writing utensils down, look up to the screen. I'm going to start with baby steps. I'm going to start with the very first equation that you were introduced to. And this is going back to, I don't know, 3rd, 4th grade. Some of you 5th grade and so on and so forth. These are called one-step equations. Why are they called one-step equations? Because it only takes one step to solve. It's up. Here's 1. X plus 2 equals 25. Here's another. And don't copy these. I'm just going to go over this myself. 12 equals y minus 8. Negative 2a equals 14. And negative 3 equals m over 4. Okay. So I'm going to do the first one, this one right here, step by step, so you guys can see the process. So, to start off, line down the equal sign. And now you can imagine the scale. Do you guys see the scale? So now that means we're going to have to keep it balanced by doing one thing to each side at the same time. So where do we start? We need to leave x by itself. So here we have addition. So what is the inverse? So we subtract 2, and whatever we do to one side, we do to the other. X equals 23. So from there, did I simplify each side? We couldn't. So did we isolate the variable? Yes, we solved. Now we're going to plot our point. Plot our point on the number line. Here it goes. Graph your number line. 0, ... 23. And here's my plot. Now please plot on the line. Some of you in the previous years you used to do this. You get papers like this, I'm like, what are they doing? Plot it on the number line. There it is. And lastly, we're going to do what? Check. So how do we check? We take the original equation, x plus 2 equals 25. And instead of writing x, what do we write, everyone? 23, 2 equals 25. So is 25 equals to 25? Yes. That's the whole process. Therefore, I want you to copy this one and do that one using the whole process. 12 equals y minus 8. Copy that and go. So now that we understand what one-step equations are, let me just go over the last two so that you can see the process. Writing utensils down, look up to the screen. Here it goes. So these two, look at this one. Line down the equal sign. What operation is here invisible? Multiplication. What is the inverse? You divide by negative 2, divide by negative 2. A equals negative 7 because this becomes a giant 1. So far so good, yeah? And this one right here, same thing, line down the equal sign. We can't simplify any side, so therefore, what operation is here? Division. The inverse is multiplication. That means we're going to multiply times that number to both sides to keep it balanced. The giant 1, we're left with m, and on this side is negative 12. Yes? All right, and obviously after step one, or one-step equations, what follows? Two-step equations. Here it goes. Here's a two-step equation, and I'm going to go over this one myself again. Writing your utensils down, I'm going to go through the whole process. And this is where it starts getting a little complicated for some of you that probably got lost in the past. Here it goes. First, line down the equal sign. Now, you don't have to be doing that. That's just for you to kind of like see the both sides and see which side you're going to be working on. So here we go. Look at this side. Can I simplify this side anymore? No. How about this side? No. So therefore, here now I have a dilemma. I have two operations. I have multiplication and I have addition. Where shall I start? Let me tell you. With equations, since they're no longer expressions, we use order of operations, but backwards. Tell your neighbor what I just said. So, what is the last step of order of operations? Addition and subtraction, right? Do we have any here? Yes, here it is. So what is the opposite of addition? Subtract 12, subtract 12. We end up with negative 5x equals 25. From there, what is the other operation? Multiplication. What is the inverse? Divide by negative 5, divide by negative 5. X equals negative 5. You good? All right, copy that one, and I'm going to send you another one so that you can work on the other one, but copy that one so you can have it as a sample. All right, here we go. Look up to the screen, please. I'm going to zoom in. Just to double check our work, here it goes. Line down the equal sign. What are my two operations on this side? Division and subtraction. So where am I going to start? So what is the opposite? Add 12, add 12. That leaves us with 5 equals m over 9. Now the 9 is dividing, so what is the opposite? Multiply times 9, so this is 45 equals m, because this becomes a giant 1. Oh, sorry. I did that to save your paying attention. M. Hands, have you got that? Okay, we got this, yes? All right, so let's move on. Now that we got done with the simple stuff, what would be the obvious next one that I'm going to introduce? 3-step, and then from there 4-step, and so on and so forth. But from this point forward, they're no longer called 3-step, 4-step. They're called MultiStep Equations. They're called what? MultiStep Equations. And of course, the very first one I introduced after those easy ones, I said, okay, guys, let me show you the easy ones that you like, the ones with fractions. Yay! All right, so writing utensils, I'm going to go over this one again just to double check that we recall it. All right, here we go. All right, writing utensils down, look up. So when we got to these, I said, some of you were like, oh, I don't like fractions. And I said, okay, good, because we're going to get rid of the fractions. How do we get rid of the fractions? I said, look at the denominators first. What is a common denominator for these three? So we're going to multiply all the numerators times 12. This times that, that's 24 over 3r. This times that, that's 36 over 4. And this times that, that's 84 over 12. Why did we do that? Because the next step is to simplify. What is 24 divided by 3? 8r plus 9 equals 7. Is this easier to solve? Yes. Copy that, please. And finish it off after you copy it. This should only take you 2 more steps. So, all right, let me help you out on this one to finish it off. Line down the equal sign. Where do I start with addition? Subtract 9, subtract 9. We end up with 8r equals negative 2. What's my last step? Divide by 8, divide by 8. Therefore, r equals negative 2 over 8. Or if we simplify it, it's what? Negative 1/4 or negative 0.25, either one. Hands if you got that. Okay, good. Now, let me show you another one. Don't copy it. Look up. Look at this one. Look at the denominators. To get rid of the fractions, tell you never what you're going to multiply all numerators by. Everyone? 20. We got this, yeah? All right. So from there, now it starts getting funner. So here, let's kick it up a notch. So look at this one. This is probably going to be the last one. I think we have one more. Anyways, here we go. Look up. Line down the equal sign. What is the first step of the process that I gave you? Simplify each side. Can we simplify this side? Yes. Yes, we can combine stuff. So what is 8x and 5x? Negative 3x, bring down to negative 21 equals to negative 15. Do you know what to do from there? Yes. Copy that and finish, please. Okay, and pretty much that's what you're going to have for tonight's home play. They just build up a little bit more on each side. So like that, you can simplify as much as you can one side, and then at the end, you're going to end up with a two-step equation that you can solve at the end. Okay? So once again, home play for tonight are 10 problems only. If you need to revisit the lesson, remember, go to the YouTube channel. Okay? Have a good one, guys. Your home play. See you guys tomorrow. Bye.